Good morning, my YouTube viewers. It is Crystal here, and I'm here this morning because I wanted to make another code review for you. And basically, I'm doing a code review on Kaggle's competition question, Contradictory, my dear Watson. And basically, I've had this competition in my competition inbox for a long time, but I never did it because I thought it was too complex for me to do it. But I've been studying TensorFlow and I've been studying BERT in particular, so I decided to have a go at it. And one of the things about this particular competition question is the fact that they give you a tutorial that will help you to submit your first piece of work. So that's what I've done. I've used this tutorial to submit my first piece of work. But one thing that I will say about the tutorial is the fact that it is 3 years old and it was written on an earlier version of TensorFlow. And because it was written on an earlier version of TensorFlow, one argument in particular was deprecated, and because that one argument in particular was deprecated, the program wouldn't run. The program just stopped, and it gave me a fault, and I didn't understand what the fault was. And as a result of that, I had to go back and look at other code, and I found some code where the program was written under TensorFlow 2.6, and on this particular piece of code where the program was written on TensorFlow 2.6, it gave an error message saying that LR was deprecated and you were supposed to use learning rate instead. It did not give that error message on TensorFlow version 2.11, so the code just wouldn't work, and it just made you confused as to why the code would work. So I went into my code and I replaced LR with learning rate, and fortunately the code worked, but I spent a good part of the day troubleshooting this, trying to figure out what the problem was. And then in addition to that, I've also used my GPU time, because you only get so many hours of GPU time a week. And because I spent all this time trying to get the code to work, I wasted a lot of GPU time as well. So I don't know what's going to happen with my GPU time, but I'll just keep struggling on and use as much GPU time as Kaggle will allow me to use. So now that you know that I had to troubleshoot this code and to get it to work, I hope you have a little bit more appreciation of what I did. And I would like to say that I was in the military about 4 decades ago, and I was a telecommunications, I was a radio relay equipment repairman, and one of my jobs was to troubleshoot broken equipment. And so in this particular instance, I wasn't troubleshooting broken equipment, but I was troubleshooting a broken program. And it still uses pretty much the same principle. And maybe I might write a blog post on that. I've got a few things that I want to write blog posts on, but it still uses the same principle. So without further ado, I'll go ahead and do the code review now that you have a little bit of behind the scenes story of what I did to actually get the code to work. No thanks to Kaggle. I think that Kaggle should be going through their tutorials and updating them. I mean, it's not fair, it's not right that they're using a 3-year-old tutorial with deprecated code. I think they should go through all their tutorials, make sure that the code isn't deprecated, and then that will help people, because the only thing it helped me do was troubleshoot. So what we'll do is we'll go ahead and carry on with the code review. First thing we'll do is we'll talk about the problem statement. So your task is to create an NLI, that's natural language, I believe, inference model that assigns labels 0, 1, 2 corresponding to entailment, neutral, and contradiction to pairs of premises and hypothesis. To make things more interesting, the train and test set include text in 15 different languages. So that's your problem statement. So it's a multi-class label. So that's what we're going to be doing. A multi-class label with 15 languages. So fortunately, they have given us a tutorial, albeit an old tutorial with deprecated code. But we can do it now after it's troubleshot and repaired. So the first thing we do after we set up our computer program and read our problem statement is we import our libraries. So we're going to import NumPy as NP, which is creates NumPy arrays and carries out numerical computations. We're going to import Pandas as PD, which creates series and data frames and also does data processing. We're going to import OS, that's a Python built-in module that goes into the operating system. We're going to import matplotlib.pyplot as PLT, which visualizes the data. And we're going to import Seaborn as SNS, that also visualizes the data. We're also going to import TensorFlow, and that's going to create our neural network. And what you need to do is, because TensorFlow goes through so many changes, you always need to print off what version of TensorFlow that you're working on. So now what we're going to do is we're going to use OS to go in and get the files that we're going to be using. So we're going to be using 3 CSV files, being train, test, and sample submission. We're going to silence the warning. I didn't originally have this in here, but because I was trying to troubleshoot my code, I thought, well, I better put it in there because it might have something to do with the code not working. So I put in this code to silence the warning, but it probably isn't essential that you have it. I set up the TPU so you can use the tensor processing unit. I didn't have that in there initially because I wasn't going to use the TPU. I was going to use the GPU because TPUs are harder to use because everybody wants to use them. So you have to wait in the queue to get to use the TPU. But because I was having so many problems troubleshooting the program, I thought, well, I better put that in there just in case that has an effect on what's going on. And then what I did was so it might not be necessary for you to put that in there, but I put it in there because, like, when you're desperate, I spent like a day trying to figure out what the problem was. And so if you don't want to put that in, you probably don't need to put that in. So then what we do is we read our files using Pandas. So we break the files into data frames. So we've got train, test, and submission data frames. So you can see the train data frame. So you've got your ID number, your premise, your hypothesis, and your language abbreviation, your language, and your label. So what we're going to be working with is the premise, hypothesis, and language and label. Look at the train shape. It was 12,120 examples by 6 columns of data. We look at the info, so you can find out that all of the columns of data except for the last one are objects. Check for any null values, and we don't have any null values, so fortunately we don't have to impute any null values, and we don't have to deal with any null values. Now we look at the test set. So the test set has different languages as well. And we don't have the last column of data, which is the label. So we don't have a label. So that is what we're going to be predicting on. Check for any null values. We don't have any null values. So that's good. And now we check for submission. So this is what Kaggle wants to see when we submit our predictions. Now what we're going to do is we're going to analyze the label. And so you can see that we have a pretty fair distribution between 0, 1, and 2. So we have 4176 zeros, 4064 twos, and 3880 ones. So we did a value count on label so you can see how many counts you have of each class. Now we put it on language ABV, put that on a disk plot. So we've got 15 different languages, and the most frequently used language is English, but we have other languages as well. And then on test, we put language ABV on a disk plot, and you can see English is the most frequently used language, but they have the other 14 languages as well. So now we create a pie chart, and this is the pie chart that was created in the tutorial. And no, I didn't originally use it, but because I was troubleshooting and I was having so many problems, I put it in there anyway. So you can see what percentage we have of each language. So English is the most frequently used language. So now we're going to prepare the data for the model. The model name is BERT Base Multilingual Case. The tokenizer is BERT Tokenizer. And you can see at the very beginning of the program, when we imported our libraries, we imported the BERT Tokenizer in TensorFlow. Now we set up a function to encode the sentence. So def encode sentence. So tokens equals list tokenizer dot tokenize s, tokens dot append sep, and then return tokenizer dot convert tokens to IDS tokens. So we encode the sentence. Machine learning is fun, and so that's the numerical equivalent that you get with each word. So now what we're going to do is we're going to define the function BERT encode. It's going to accept the arguments, premises, hypothesis, and tokenizer. So num examples equals len hypothesis. Sentence 1 equals tf.ragged.constant. Encode sentences for S in NP array hypothesis. Sentence 2 equals tf.ragged.constant. Encode sentences for S in NP array premise. So it's going to work on the first sentence, and then it'll work on the second sentence. CLS equals tokenizer.convert tokens to IDS, and it says CLS times sentence 1's.shape 0. Input word IDS equals tf.concat CLS sentence 1 sentence 2 axis -1. So now we have our input mask equals tf.1's like input word IDS dot to tensor. So we convert that to a tensor. Type CLS equals tf.zeros like CLS. Type S1 equals tf.zeros like sentence 1. Type S2 equals tf.1's like sentence 2. input type IDS equals tf.concat, type CLS, type S1, type S2, axis equals 1, 2 tensor. And then we have our inputs, is input word IDS, and the inputs are going to be a dictionary as well. It's going to be input words IDS 2 tensor, input mask is input mask, input type IDS equals input type IDS, and then the function returns the inputs. So the inputs are in the form of a dictionary. So train input equals BERT encode train.premise.values, train.hypothesis.values, and tokenizer. Now what we're going to do is we're going to define the model, and this is where I had the most trouble trying to troubleshoot what was going on. And it was hard. I had to look at other people's models code as well, and that's when I found out that LR has been deprecated. And that's why I do think that Kaggle needs to go through all these tutorials and make sure that the code in those tutorials hasn't been deprecated, because somebody else would have just given up, but I just kept trying and looking at other people's code to see if I could find the problem. So you have def build model, so BERT encoder equals tf BERT model dot from pre-trained model and model name. And then we've got model name up here somewhere, don't we? Oh, but model name equals BERT encoder. It says model name is up here, is BERT base multilingual cased. Input word IDS equals tf.chars.input, shape equals none, def type equals tf.int32, name equals input word IDS. Input mask equals tf.chars.input, shape equals none, dtype equals tf.int32, name equals input mask. Input type IDS equals tf.chars.input, shape equals none, dtype equals tf.int32, name equals int type IDS. So now we're going to do embedding equals BERT encoder, input word IDS, input mask, input type IDS, and 0. Output equals tf.chars.flares, dense is 3, activation equals softmax, embedding equals all the rows and the first column. Model equals tf.chars.model, inputs equals input word IDS, input mask, input type IDS, outputs equals output, model.compile, tf chars optimizers, atom, learning rate. That is what the problem was, because they were saying LR, which was deprecated, and it didn't even give me an error saying LR was deprecated. It just went into error. So it said learning, and then it didn't go into error until it tried to train the model. So learning rate equals 1e negative 5, loss equals sparse categorical cross entropy, and metrics equals accuracy, and then you return the model. So now we've got with strategy.scope. So that with strategy.scope goes to the very beginning of the program where we put in that code about using the TPUs. So if you don't use the code about the TPUs, then you don't need to use with strategy.scope. But I was so, trying to find out what the problem was, trying to completely recreate the code that worked to try to find out why my code wasn't working, that I put it in there. But if you're not going to use a TPU, you probably don't need to use the code at the beginning of the program that refers to TPUs, and you wouldn't need to use with strategy.scope. So model equals build model, and model summary. So now we've got your model summary. I spent a lot of time looking at the model summary when I was troubleshooting. So now we've got a statement classifier PNG, so you can see what the statement looks like. It takes the three inputs, the input word IDS, input mask, input type IDS, and puts it into the BERT TF model. And it has a slicing op lambda, and then it returns a dense. And now we have a statement classifier with shape info, so you can see what it's doing with the shape. So that's good. Now what we're going to do is we're going to train the model, and this is where my program refused to work, and I had to try to figure out what the problem was. But model.fit, train input, train labels.values, epochs equals 5, verbose equals 1, batch size equals 16, validation split equals 0.1. I let it iterate through 5 times, and if I had iterated it through more, then I probably would have got a better accuracy. And you could have also set it up for early stopping, which I didn't do. I didn't set it up for early stopping, but it took a really long time just for it to iterate through these 5 epochs. And then in addition to iterating through the 5 epochs, I also had to save my work. And it takes just as long a time to save your work as it does to train it. So we could have gotten better accuracy if we'd iterated it more, like maybe 10 epochs, but I just couldn't afford to sit and watch it train an extra 5 epochs. Now we're going to evaluate the model. Says test input equals BERT encode test premise.values, test hypothesis.values, tokenizers, and then we set up our predictions. So predictions equals np argmax I for I and model.predict test input, and then we're going to take the predictions and we're going to put it in an np array. Predictions equals np.array predictions, and then we're going to flatten the predictions. Predictions equals np.array.flatten predictions, and then so we've got a flattened NumPy array of the predictions. We're going to put the predictions on a sysplot, on a dist plot, so you can see that there's relatively good distribution of examples of 0, 1, and 2. Then what we're going to do after we've done that, we're going to prepare a submission. Submission prediction equals predictions. Submission.toCSV equals submission.CSV index equals false. Submission equals pd.readCSV, submission CSV, submission. So you can see this is our submission. This is what we have submitted to Kaggle, and I got a 65% accuracy, which was a lot higher level of accuracy that I previously have had. So we can go over here to Contradictory, My Dear Watson, and we can look on the leaderboard. And so I'm 65,158. And I'm number 38 on the leaderboard. So obviously, there's a lot of people higher than me. I could have trained it more, and if I had trained it more, then I may have had a better level of accuracy. I also found out some more things that you can do because I read an article. I read an article on the internet about how to win a Kaggle competition, and they gave some tips on how to win a Kaggle competition as well, which is interesting. I might try some of those tips. But you can see with Contradictory, My Dear Watson, they only have 69 teams because a lot of people are not going to enter this competition because of the complexity of the competition, and I just wonder how many people give up because the code in the tutorial is deprecated. So I did actually put a comment on the tutorial saying that it was old code. I don't know if they're going to take any notice of anything I say, but I did put a code in there, a comment in there saying it's old code, and they really should do that. Kaggle really should go through all of their tutorials and update the code, because it's not fair. It's not fair for people learning data science to be working with deprecated code and have the code not work, and they don't understand why the code isn't working. So I'm going to go ahead and conclude this video. Thank you so much for watching my code review. Thank you so much for listening to me talk about all the problems that I had with this competition. And if you like my video, please like, subscribe, and share. And thank you to my subscribers for supporting my channel. And I look forward to making new code reviews for you in the future.